Good afternoon, good evening. How are you doing? I'm making a little video over similarity. Okay, if you missed class on Monday, February 3rd, you're in luck. All right, we're talking about similar triangles or similar shapes in general, similar figures. In general, similar, and for these examples, similar triangles triangles with the same angle measures but different side lengths. Their side lengths, though, are related. Okay, they are related, all right, but they are not equal. They're not congruent. Okay, there is a relation between the two of them. So I'll tell you that triangle ABC, okay, is similar to triangle XYZ. All right, so what does that mean? Well, that means their angles are the same. All right, so angle A is congruent to angle X, angle B to Y, and Z and C. All right, their sides are also proportional. Okay, so let's look at this. So I'm going to use my colors here. A, C, and XZ match up. All right, well, how will I know that? I'll explain that in a second. A to B matches up with X to Y. Right here, it's easy to see, right? It's easy to tell because they are not, neither of these triangles are rotated at all. All right. Sometimes it's not as easy to see like this. So the triangles will be rotated around. All right. How I look at it sometimes though is you look at the similarity statement. All right. A, B are my first two letters. X, Y are the first two here. B, C are the next two. Y, Z are the next two after that. And then A to C. I'm sorry to use red. Let's use green. AC matches with XZ. All right, so that's how you could think of it. Also, I mean, if you can see how these are aligned on top of each other like that. All right, they're stacked. You can write a similarity statement like this. A, B, C is similar to X, Y, Z, and it's easier to match those up. This single squiggle here means similar. I've been saying it a lot. All right, that means similar. So A, B, X, Y, B, C, Y, Z. Then this will be a little bit cleaner. A to C, X to Z. All right. Next part of this chart asks for a scale factor, so we need some numbers. So I'm going to call this 6, this 25. This I'll put an X, and this will be 8. So we have to figure out our scale factor. We can write our scale factor in two ways. I can go from big to small or small to big. And what do I mean by that? Well, the scale factor be represented as 25 over 8, which is 3.125. That would be considered an enlargement, meaning, all right, I multiply 8 by 3.125 to get 25. Or you can write it as a reduction, okay, because 3.125 is greater than 1, that's an enlargement. A reduction will be 0.32. Okay, so I multiply 25 by 0.32 and I'll get 8. When dealing with similar figures, similar shapes, triangles, rectangles, whatever the case may be, setting up proportions or using proportions will help us solve for a missing side. All right, so here, I want to use the numbers that I have. Well, what do I have? I have 25 over 8 equals. A proportion is a fraction equal to a fraction, remember? Since I went from left to right, I went from the big triangle to the small triangle. Okay, I'm going to go from 6 over X. That is not the same as this. You cannot do that. These are not the same thing. Don't do that, okay? I can, however, say 8 over 25 is equal to X over 6. Those are reciprocals, all right? Those are reciprocals. So if I wanted to solve this proportion and I was intimidated by the x in the denominator, I could use the reciprocal. 8 over 25 equals x over 6. And that's a little bit easier to solve because then I just have to multiply both sides by 6. So how would you do that in your calculator? I would do 6 times 8 divided by 25. Okay, and x should be, either way, x should be 1.92. All right. All right, let's try another one. We're going to draw the triangles for this one. Okay, so I'm going to say, draw this triangle like this. And I'll draw this triangle just a little smaller, and rotate it a little bit. So I'll say this triangle BCA is similar to triangle ZYX. And I'm going to call this B, and this C, that'll be my right angle, and this will be A. Well, this will be the right angle there. So our job is to, label the triangle on the right, and by using our corresponding sides and corresponding sides from the similarity statement. Well, I know that C is the right angle here, and C is my second letter, so Y must be the right angle there. I know that B to C is my shorter side, so this must be the shorter side there. Well, what is that? What does B to C match up with? BC aligns with ZY, so that is my Z, and that means this is X. AB, or BA, the first letter and the third letter, aligns with ZX, the first letter and the third letter. C to A should align with Y to X there. Let's do some numbers. I'm going to call this 10. I'm going to call this 25. I'm going to call this X, and I'm going to call this 8. So we need to find the scale factor first. Which side corresponds? You can use the order of the letters, or I can use the colors. The colors are a great tool. You will be provided with markers if you want for the test to help you out. But let's try this. 10 should match up with 8, which is 1.25, or I could do 8 over 10, which is 0.8. Set up a proportion. I'm going to set up a proportion to solve here. Okay, let's do our setup. Go ahead and try the setup. Set it up. Use what you have. Good things. 10 over 8 is 25 over x, or you could have done 8 over 10 is equal to x over 25. Just stay consistent, okay? What do I mean by that? I mean stay consistent. If you're going 10 to 8, so left to right, big to small, I have to stay consistent and go 25 to x. Okay, I can't go 10 over 8 equals x over 25. It's not going to work. Your answer will be incorrect. So I'm going to use the second proportion here to solve because x is in the numerator. And then I'm just going to multiply both sides by 25. So some people would do 25 times 8 and then divide by 10, and you should get 20. Last one. Last one is a little bit funky. Oh boy, where did it go? Where's my last one? Oh, it's gone. Oh, that's solid. Okay. We're experiencing technical difficulties. Please hold. There it is. Okay, so new one. All right, so I want you to draw a big triangle there. Big triangle. There we go. And then I'm going to cut it right there. Well, how many triangles do you see here? How many do you see? Hopefully, you should say 2. You should see 2. Or I have the big one, like that, and the smaller one, like that. For the sake of this, I'm going to use different letters. So I'm going to say A, B, C, and then Z, Y, X. And I'm going to say, all right, this corresponds with this, ZY with AB, and then AC to ZX. So our similarity statement should look like this. Triangle ABC is similar to triangle ZYX. I'm going to say that this is 25, and then this is 8. And this is my X, and this is 6, so this part is 6, and this whole thing is X. So scale factor, to go from big to small. From small to big, 25 over 8 again. Same numbers, all right, different representation. I could also go 8 over 25, remember, which was 0.32. All right, it's a little bit different this time. All right, so it's a little bit different than the first problem that we did, okay? But our setup is pretty similar. Hey, now, similar triangle, similar setup, wow. 25 over 8, so our 2 green sides equal to X over 6. So our 2 red sides. So if you look at the first one, it was 6 over X. All right, so it's a little different. Well, that's nice for us because X is already in the numerator. So I can just, to do the work, I can just multiply by 6 right away and do 6 times 25 divided by 8, and I get 18.75. All right, when you see an overlapping triangle problem like this, okay, it's helpful, like this one here, it's helpful to take them apart. Like you may have to take them apart on an assessment, okay, and just break it down that way. All right, hopefully that helped. If you have any questions, please come see Mr. Lakin or myself. Have a great rest of your day. Adios.